Okay, there is a complex number u which is 3 minus iota. So what will be its conjugate pair? 3 plus iota. Okay. And we will be needing here u star minus u. So what is this u star minus u? That is going to be 2 iota. Okay. It says on an Argand diagram with origin O. So let's have that Argand diagram. Okay, the Argand diagram. Origin is O, and the point A is to represent U, which is 3 minus iota. 1, 2, 3, and here is minus iota. That is your A. B is U star. So 1, 2, 3, and here is your 1. Okay, so this is your B. And then it says C is going to represent U star minus U. So it is going to be here, this 2. This has to be marked with the point C. Okay. Now it says what type of a quadrilateral is OABC. So if you only know that how to show these points on an Argand diagram, you could have easily got these 4 marks. So what shape is this, Bacho? This is a parallelogram. Okay. Now let's see what is the next part. It says showing a working, and without using a calculator, we have to write this u star over u in the form of x plus iota y. So that is a very simple kind of a thing. So this u star over u. This is the most frequently asked question in your past papers, where you have to write a fraction in x plus iota form. This is 3 plus iota over 3 minus iota. So what should I do, bacho? Shanze, what should I? Huh? Yeah, you will be multiplying and dividing it with 3 plus iota over 3 plus iota. So if you knew that what is 3 plus iota whole square, then you can easily see that this is 8 plus 6 iota over 10. And I have to write this as 8 over 10 is 4 over 5, and 6 over 10 is 3 over 5 iota. Okay? So you should be very quick in writing a fraction whose numerator, denominator, they are complex numbers into this x plus iota form. Okay? Now, let's see what's next. By considering the argument of u star over u. So this is a big clue for us. By considering the argument of u star over u, we have to prove that the tan inverse of 3 over 4 is 2 tan inverse of 1 over 3. I'll give you time to try this first. Okay, polar form is our savior in this part here to prove that. Otherwise, there's no way you cannot prove this, that this tan inverse of 3 over 4 is 2 tan inverse of 1 over 3. Let me show how to do that. Okay, so we have to prove that this tan inverse of 3 over 4, that is equal to 2 tan inverse of 1 over 3. Before we start proving this, you need to have something in your pocket. Now, one thing that you need, that is, what is the argument of, let's say, let me write the same, u star over u. Can we say that the argument of u star over u is argument of u star minus argument of u? Yes, bacho? Polar form tells us this. Okay. Second thing that you need to remember is that tan of minus x can be written as minus tan of x. Okay, tan of minus x can be written as minus tan of x, and this applies to the inverse as well. Okay, so tan inverse of minus x can be written as minus tan inverse of x. Okay, first of all, the first relation, this is your u star over u. So as it is, can I say argument of u star over u is tan inverse of b over a? Yes? You see the fives are cancelled? So that is tan inverse of 3 over 4. That is the argument of u star over u. That is our first relation here. Okay? Second thing, using this, you should allow me to say that this argument of u star over u is argument. You see, this is the pure mathematics, the real face of the pure mathematics. Okay, now argument of u star, look at this, is your, look at this is your u star. So can I say this is going to be tan inverse of 1 over 3? Yes, bacho? And then argument of u, this is your u over here, this one. So this is going to be minus tan inverse of minus 1 over 3. So I can take this minus out here. So this will become plus. So that is going to be 2 tan inverse of 1 over 3. And this is your second relation here. That is argument of u star over u. So from 1 and 2, we can say that from 1 and 2, this has been proven that tan inverse of 3 over 4 is 2 tan inverse of 1 over 3. So that is how this polar form helps you to prove, such complicated things. Okay.